Hello and welcome back. What we're going to do here is we're going to solve this for x. We're going to use some double angle formulas here. The double angle formulas right here. There's going to be x values there and there. So just have that solved there. But we're going to solve for x in this problem. We're going to solve this on the interval for 0 to 2 pi. Okay, 0 to 2 pi. Now, once we have a square there, now there's a bunch of different ways we could approach this. Probably the easiest is we're going to factor this out. So when we have this, we have sine of 2x. And if you recall a little algebra step, we're going to actually take this and we're going to FOIL this through. And so what that gives us is it's going to give us sine squared of 2x. Our middle terms is we're going to have 2 sine of 2x times cosine of 2x. And then what we're going to have next is this portion right here. We're going to have this right there, which can be cosine squared of 2x, and that's going to equal 1. Now, if you realize we have sine and cosine squared, and you should know one of the trig identities is when we have sine squared of u, or whatever I mean, plus cosine squared of u. Okay, that's going to equal 1. So our u is 2x in this case. Since they're both the same, we know that this together is going to equal 1. So we're going to have 1 plus 2 sine of 2x cosine of 2x there. And that's going to equal 1. We're going to subtract the 1 from both sides. So now we have 2 sine of 2x cosine of 2x, and that's going to equal 0. I'm going to divide by 2, so now we have sine of 2x cosine of 2x. That's going to equal 0. And now we're going to use one of our identities to help us figure this out. So right here, I think I'm going to go with 2 sine of cosine x. All right, we're going to substitute that in for this portion. So we're going to have 2 sine of x cosine of x. And then we're going to take this portion, I'll make this in green, and we're going to plug one of these values in here. And for this portion, let's take either one of these would be fine. I'm just going to take that one right there, and that's going to be times our 2 cosine squared of x minus 1, and that's going to equal 0. All right, both these are equal to 0. So now from here, we're going to solve this. Now notice that we have all being multiply, and we have 2 and 2, so that doesn't matter, but they're all going to equal 0. So now what we can do is we can actually take each one of these multiples and we can say sine of x equaling 0. We can have cosine of x equaling 0. And we can also have 2 cosine squared of x minus 1, that equaling 0, and solve and find all these values for x on the interval from, remember, we're looking for the interval from 0 to 2 pi. So when we solve for this one, well, x is going to be the inverse sine of x, or inverse sine of 0. And so I have an answer right here, okay, for my values of when is x 0? That's going to be at 0 and pi. Okay. For cosine, when we solve this one, we take the inverse cosine of 0, and then we have the inverse cosine of 0. That's going to be pi over 2 and 3 pi over 2. So we have those values there. The next one is when we have this, we're going to solve this one, and when we go over here, we're going to have 1, and we're going to divide by 2, and that equals cosine squared of x. We get a 1/2. We're going to take the square root of that. And when you take the square root, we're going to have 1 plus and minus the square root of 2. We're going to solve for this. Take the inverse cosine. We're going to have plus and minus 1 over the square root of 2. And that's going to be in all the quadrants, first, second, third, and fourth. And we know that we have a 1 radical 2 for a value. So this is going to be all the multiples of, I believe, a 45-degree angle. So what we have is pi over 4. We'll have in the second quadrant 3 pi over 4. Third quadrant is 5 pi over 4. And then finally, the fourth quadrant is going to be 7 pi over 4. And so from here, we can identify that all of our solutions from 0 to 2 pi for x are going to be, well, we can write them all out. We have 0, pi over 4. We have pi over 2. We have pi. We'll have, well, I forgot 3 pi over 4 right there. I didn't put them in order. Then we have 5 pi over 4, 3 pi over 2, and then 7 pi over 4 for our final answer. So all of these solutions are the solutions to this original equation right here. So we did a little algebra, factoring it through, realizing we can use a fundamental trig identity to simplify this, make this 1 and spread to the other side, and then we can go through and solve the remaining portions of that. And there we go. Okay, so all these will work out just the way we want them. All right, well, I'm going to try another problem. So hopefully this helps you out, and good luck and God bless the rest of the problems.